Hello everyone, this is a demo of Cortex integration with Apache Pulsar. Apache Pulsar is a Kafka kind of message broker. We are going to now show how to use Cortex as a storage backend for Pulsar. The pull request for the integration can be found here, and the integration folder is this. There is a README here showing the high-level overview of what the integration is about, and the documentation.md has detailed steps on how to reproduce it. Let's go use the documentation.md. So this is the plan of action today. We are going to first set up Cortex on a virtual machine. We are going to then use AWS CLI to check the bucket data on Cortex S3. We will then set up Pulsar to use Cortex as tired storage backend. We will make some hacky adjustments to make sure Cortex accepts payloads sent by Pulsar. We will then publish messages on a Pulsar topic, and then we offload the topic messages to S3, Cortex S3. How do we know that the integration has succeeded? We will prove it by two ways. One is that we will take a look at the internal stats of the topic in Pulsar and then verify that the offload has happened. We will cross-check the same by going to Cortex S3, and then we'll check the S3 bucket and we will notice the topic data saved there. And finally, we will replay data from the earliest message in the topic via Pulsar, which means that we are getting data from Cortex S3 through Pulsar. For this demo, we need Python 3, pip 3, and Cortex VM setup. I'm using Oracle VirtualBox for virtualization, but you may choose a different platform as well. First, I'm going to show you my workspace. It has the Cortex repository clone. I have Cortex virtual machine image. And then I have this terminal setup nicely. So with all the tabs, so in this tab, I'm going to SSH to Cortex virtual machine and work through. In this tab, I'm going to run Apache Pulsar. I'm going to run AWS CLI and Pulsar admin commands from here. I'm going to publish messages to Pulsar topic from here. From here, I'm going to subscribe to a Pulsar topic and listen to the messages and print all the messages on the console. And from here, I'm going to read messages from the earliest message on the topic and print. This is miscellaneous tab, which I'll use if I need it. Okay, first let's take a look at the contents of the integration folder. So here we have 3 Python files. One of them is the Pulsar producer, which publishes messages to a test topic. Pulsar reader, which reads messages from the earliest message on the topic. Pulsar subscribe to a topic, gets the messages from Pulsar and then prints them on console. The setup folder has files needed to get Pulsar running. The .sh file is basically an export of AWS access key and secret key. We have to replace these with the actual values which we get from Cortex S3 though before running Pulsar. And in the conf, there are 2 conf files which we have to copy to Pulsar's configuration directory before running it. That's about the contents. Now let's follow through with our plan. The first step is to set up Cortex on a VM. The detailed steps can be found in Cortex repository in this piece of documentation. Let's follow on these quickly. Yeah, first we need to download the Cortex image, virtual machine image, which I already have here. So let's get going with it. I'll import the image here. Okay, let's get virtual machine. Okay, I'm going to replace the name, change the name to Cortex demo. VirtualBox is going to load this image and then get the VM ready for us. Meanwhile, let's take a peek ahead of what we are going to do. So we are going to open the VM console, log in, become root, and set the host name first. So Cortex demo VM is ready. So we'll start it. I'll try and get this to a decent scale for you. Okay, this looks better. I'm going to log in, become super user. Okay, before we do anything, I'll try and set the date first. This is a common issue with VMs. The date is off. So because the date in the VM is UTC, I'm going to, but it says the date is UTC, but it takes the time from my machine. So I'm going to push the time here by my by the offset of my time zone. Right, this sounds correct. Now I'm going to set the host name as per the documentation. I'm not able to copy paste commands directly into the VM because I don't have the mouse integration. Okay, what shall we name the machine? The virtual machine. I'm going to name this local.seagate.com. Right. So the name sticks. There are a bunch of, in the next step, there are a bunch of steps which are specific for Oracle VirtualBox. I'm going to do them now. I'll redirect the output of IAPL to a temp file because it is easy to view there. IAPL.txt. I'm going to open the file and show you what the command had given us as output. So this command gives us the network devices available. So we have loopback and 3 more devices here. ENP0S8, ENP0S9, ENP0S17. This does not quite match with the documentation here. So we are going to map ENP0S3 to ENP0S17. I have done this earlier. This has to be mapped to, yeah, ENP0S3 has to be mapped to 0S17 to get this working. Otherwise, you will face issues like unreachable VM and so on. Okay, we did this, we got the output. Now, we have to note down the MAC addresses of each of these network devices. Right, the MAC address is here in the link section. This is the MAC address. These three are the MAC addresses. If you can see my mouse. So all the three MAC addresses have the same first 3 bytes. They seem to remain constant across deployment. So I'm going to note these MAC addresses down. ENP0S8 is 42 6A DE ENP0S9 is 08027 9A 311A 0S17 is A7 3C4A. The values. Now let's change a bunch of scripts. You go to etc sysconfig network. It's not underscore, it is this minus. This has to be fixed in the documentation. I have raised a pull request for this. ENS32. So if you remember, we have to map ENS32 with ENS3. There is no ENS3 in our case, so we will map it to ENS17. So ENP0S17. So 32 goes with 0S17. We are going to change after boot proto. We're going to say the hardware address which we want to map to is 080027 and then A73C4A. If you let's complete this for 33 as well. So 33 maps to S8, 34 maps to S9. At 0027. This is 33. So S8, 6A, DE. So for 34 is 080027 9A31. I'll highlight it for easier view. Right. Looks good. Thirty-four, 33 is 426ADE. Good. 32 is A73C4A. Great. Next, we power off the machine. Okay. Power off. Let's go to VirtualBox to restart this. The machine powered off, so I'm going to start it. Machine up again. So what these three network scripts seem to do is that they are creating three network devices. They are mapping the hardware addresses of the VM with three network devices. Let's become super user. Let's see if date is off by too much, little bit. So I'm going to add 1 second to it. Yeah, this is good enough. Now we have to run, but yeah, we have to run the stuff which gets Cortex running. I don't want to do it in this crappy terminal, so I will SSH into the machine and do it. For the SSH to work, for me to be able to SSH into the machine though, I have to set my /etc host. So first of all, I had to find the IP addresses which are exposed by this VM. Txt. I retype the output of ifconfig. Okay, so 32 is on 138, 33 is on 182, 34 is on 140. These are the three IP addresses which I will come to note down. 138, 182, 140. In that order. So 138, 130, 182, 140. Why do I note down these? How do I know these are these correspond to the management and public IPs? That's because in the documentation here, we have a mapping of the network device and what they are intended for. So the management portal is available on this IP. The public host names are available. The public IP is on this this IP. That is what we found out based on the network device. What this allows Cortex to do is to have separate security policies for each of the network devices. I'm guessing that is a common practice. So I'm thinking that's what must be the reason behind that, doing this in Cortex as well. So this is my local machine. In my local machine, I go to /etc host. Okay, so for the management, I'm going to use management.seagate.com as the management portal's CNAME. So this is, I've made this 138. So I'm going to have a set of names mapped for the public address, which is 182. I'm going to use the first name local.seagate.com to SSH to the machine. I'm going to use s3.seagate.com as an endpoint for S3. I'm not going to use the rest in this demo. Okay, so we are able to change the /etc host. Are we able to SSH to the machine? Yeah, we are not. (182) should be the public IP. Okay. Let's take a look at the network mapping if we have done it correctly. So this was the existing configuration. (138), 182, 140. Okay, let's switch these up and see if things work out. Let's use 138 as SSH IP. 138. Does this work? Oh yeah. So this is probably something we need to change in the documentation. But then let's find out where management portal runs from. It's obviously both the public and management cannot be in the same IP. So where could management be running from? It's either 140 or 182. Let's try 140 first. Yeah. So it seems to work fine, but this is an issue with the documentation and it is a surprise. So I'm going to log this issue in the common issues. Okay, so let's log into the machine. Okay, I SSH'd into the virtual machine, became root. Where's the documentation? I became root. So let's continue with setting up Cortex. Where did we branch off from? We branched off from here. So we should first bootstrap the service. So what this script seems to do is that it sets up a bunch of services starting from HA proxy, then it configured the /etc hosts for the virtual machine. I can show you that here. vi/etc/host. You can see that there is an additional entry here. It is mapping to 182. I wonder whether the bootstrap script encounters the same issues as we did. Let's check the IP again. Oh, so we got the IP right, 138, but the bootstrap script did not get it right. So let's see how many problems this can create for us. I don't think this is necessary because we are doing everything from our own machine here. Okay. Epoxy stuff, it's restarting epoxy. I don't know what this is. RabbitMQ server, Elasticsearch, S3 Arc server. Okay, let's wait until motor starts. Because we have some time, let's take a peek ahead. Ensure that you have configured your IP4 network. Into the virtual box, devices, network. So these are the 3 adapters alive, one each for the network devices in the VM. So this is a bridged adapter. All 3 are bridged adapters, and they are attached to the bridged adapter, which ultimately is what my network, my host machine uses. So this is the same network my host machine uses. Hopefully we don't have to open this VM again from here. We'll do everything from SSH from now on. Okay. Motor started up, 2 phases, starting S3 servers. You can see the services which are up. This is what we get. This is the status of HCTL, which we get later when we check the Cortex status. You can see the image here. Okay, something is happening with RabbitMQ CTL. Okay, I think we are good. Let's check the status. Yeah, so the same services. So everything seems to be fine. Let's check the status of all these services. See how I am able to copy and paste comments. Much better experience. So there are 8 services here. Let's count the statuses. Let's count the green active running. 1, 2, 3, 4, 5, 6, 7. I'm counting number 7. Oh wait, I think the last service was not quite useful. Okay, now we have 8 services which are active and running. Oops. If any of these services are not running, you can try these remedies. We don't have to because everything seems to be fine. We have already got these set up. Next, we have to run S3 sanity test. There are some S3 sanity scripts which are there in the VM. We will run them with this endpoint. I'm guessing the same S3 sanity test will work for AWS as well, but you have to give the IP of AWS. Or no, maybe it may not work because the credentials will be different. Yeah. So we have S3 sanity. It's successfully completed. So what it does is that it creates an account, it somehow generates some credentials out magically, creates an account. Oh, I think they have explained it here. Creates an account, creates a user bucket, puts object, deletes all above in the reverse order. So it cleans up neatly after itself. Now, using the management IP, let's refer to these instructions and why would we want to do that? Oh, I think this is enough for our purposes. So we have set up the VM, we have set up the etc host, we did some sanity check for the server, and this is important. We have to change the configuration of Cortex. This is what we mean by, where is this? Yeah. We make some hacky adjustments. This is one of the hacky adjustments which we have to make for Cortex and Pulsar to play nice together. Oh, sorry. Cortex is deployed in the opt directory. Conf s3. The layout ID. The layout ID is 9 by default. We will replace it with 1. What is this layout ID? I will explain this briefly as per my understanding. Based on the ID, Cortex chooses a unit size based on which it lays out the object. Because Cortex is an object store, it needs a unit size of memory, unit size of storage, right? So the default size is, default layout ID is 9, which corresponds to, you can see here, 1 MB. Right. This is, there is an issue with using well, I'll explain what the issue is later. Maybe you can read the issue which I raised with Cortex team. Anyway, so we change the layout ID to 1, which makes the unit size 4K, which is small, and that helps Cortex avoid the issue. Okay, now we change the configuration. So we have to restart the service, right? How do we restart it? We do it as per the instructions. Oh, it is the same instruction document as the setup, but somewhere down below there are instructions to restart. How do we do that? We shut down Cortex and then we restart it. Stop all S3 IO. We don't have any S3 IO. We did not do anything yet. Log into the virtual expense and become super user, then run his CTL shutdown. So let's run his CTL shutdown, then we power off. Okay. Restart the machine, solves all the issues. What is, okay, then let's take a peek ahead. So then we power it back up, we become super, we restart these two services and then run his CTL stuff. Okay, simple. So if we do not change this layout ID, there is a chance that Pulsar is not able to upload the topic data to S3 bucket. the kind of errors you see will say that multi-part upload to S3 server failed. Again, that stuff can be, you can consult the issue link and see the details. I'm just saying this aloud so that just in case you forget to change this file and see the issue in Pulsar logs, you can come back, change the config, restart Cortex, and then get going. Okay, so there is some error, but I don't think that matters because we are going to power off the system anyways. Okay, power off the machine. Let's restart it. Okay. We won't bother with the VirtualBox UI. We will SSH to the machine. This is much better. Do you have to log in here to get it working? Yeah. Let's log into the virtual machine. Now can we connect to the VM? Okay, well, let's take a look at the IP config again. ifconfig. Okay, 138, 182, 140. 140. Okay. etc host 138, 140. So 92.168.0.40. Okay, so now the machine moved to this IP, I guess, for some reason. I forgot. 140. Okay, so what is management available in? Yeah, it should not work. Is there the 138 or 182? There are some certificate issues, so we have to change the host here and then check. Let's try for 138. Yeah, so it is 138. For some reason, the IP addresses of the network interface has changed. But anyway, let's get back to our demo. So we are able to SSH into the machine again. Why did we go through this? Because we wanted to restart Cortex. How do we restart it? We restart these two services. Or we can do it again. Let's check the date. Okay, 2 seconds ahead, maybe. It's 2 seconds. Yeah, we are good. Now let me restart these two services. Next, I'm going to run HCTL start, and this should take care of everything. Okay, this might take some time. So meanwhile, so this finishes the restart. So where are we? In setting up Cortex, we restart the Cortex server and then we set the date. We are paranoid, so we keep setting the date always when we restart the machine. That is a good practice. So we have to configure the GUI. Okay, we have to do this so that we can generate an access key and secret key, which Pulsar can use and which we can use with S3 CLI and see what's present in the buckets. So we have to go to /preboarding/welcome. Start, acceptance. We apply and continue. This portal is sometimes ridiculously slow, and the way I got around it a couple of times is to not load the server too much. I mean, if you think the server is too slow and your requests are failing, you can see the network calls here in DevTools. If there are too many failures, then you should let the server relax, wait for 30 seconds or more, and then send a request. That next request has a better chance of succeeding. Okay, I don't want to do all this onboarding, so I will go to the dashboard. I'll manage S3 account, add a new account. Let's call it test. Now, this is why we configured the GUI. We wanted this access key and secret key. So I'm going to download this key into my workspace. This is my workspace folder, if you remember. So the credentials.csv. Yeah, so this is the access key and this is the secret. We have to use these to set out AWS credentials. But that's me going ahead. Let's stick to the plan. So we have configured the GUI, we got the access key and secret. Next, setting up AWS CLI. Let's back up a little bit and see where we are in this documentation. So we have set up Cortex on a VM. It took so much time, but we are there now. Now let's go to the second step, which we are setting up the AWS CLI to be able to query, to be able to ls the buckets and other information. First, ensure that the S3 server of Cortex is working. Okay. One way to check that is to run the sanity check here, which, if you remember, we have done in the setup of Cortex. I don't want to do that because I'm pretty sure that things are working fine. We'll get there when we need it. So we have to set up AWS CLI and AWS CLI plugin endpoint. I have a separate terminal setup for that. AWS CLI. AWS CLI lets us run commands against AWS server. The plugin endpoint lets us use S3 protocol to connect to different endpoint. In this case, Cortex S3 server. Okay. A lot of noise, but I already have both these packages installed. That's why it was so quick. It might take a lot of time. So I have to set up the config, AWS config. I already have this set up here. If you want the same, you have to add this to your config file. What this says is that we are activating a plugin, and then we are adding some configuration to a profile called SG. And for that profile, the endpoint URL is this, s3.seagate. And then we have to change the credentials file. Again, what we are doing here is that for this SG AWS profile, we are setting the AWS key. I already have an older key, so I'm going to replace it with what we got from GUI. Okay, I have the access key and secret key set up. Normally, people would already have some other profiles here, usually the default profile and so on. So this is a way to isolate your profiles from other AWS profiles which you might already have. Now, let's see what buckets are there in our Cortex S3 server. The difference between request time and current time is too large. See, this is the kind of error you get when your date is off. What do we do to fix it? We go to the VM, check the date. We see that, yeah, I think one of the times when we powered off and brought the system back up, probably during the restart we did for SCTL to get back up, the time got reset to the UTC. So I have to get the offset back again. Right. So now we should be able to take a look at there are no buckets available now. We just brought up the server, so it has to be empty. So I'm creating a bucket called Pulsar topic test. This is the next step, set up S3 bucket for offloading topic messages. So this is where all the topic messages, the older topic messages will go and stay. We'll use the bucket to offload older messages. Now, we finished one more step, so let's roll back to the steps. Yeah, the third step is to set up Pulsar to use Cortex as tied storage backend. And to do that, this is the Apache Pulsar website. You can find the documentation and the other stuff here. So we need to download, go to downloads. We have to download the binary and the offloaders bin. ls. I already downloaded those two files. I have saved them safely in others. Okay, I think I don't have them saved, I guess, so I have to download. I probably deleted them by accident. So we have a few seconds. So let's use that to peek ahead. Yeah. So we untar the binary and the offloaders star. Then we cd into the Pulsar directory. This is the Pulsar home. All our work regarding Pulsar will be done from here. Okay. We got one of the tars already. So this is the bin tar, this is the offloader star. Tar minus xvf. xvf. Noisy. Very noisy. So we have the folder. Next we untar offloaders. So each offloader which you write to support a backend should be in the form of a nar directory, nar file. You can see the details in Pulsar documentation. So in this case, this offloader uses file system as backend. This offloader supports a bunch of backends. One of them is S3, the others are GCP and a couple of others which you can see in the documentation. Now let's get into the Apache directory. This is Pulsar home. This is the Pulsar home directory. So after getting here, we copy the offloaders folder into this directory. So in this folder, there is this offloaders folder is what we are going to copy. Offloaders to here. It's a directory. What next? Yeah. So from the Cortx repository, from the integration folder, I have to copy these files. So I'll go to Cortex repository, doc integrations, Pulsar, setup. Setup has all the files for Pulsar. which Pulsar needs. So get the ENV stuff. Let's start integrations Pulsar setup. Get all the files in configuration and copy them into this configuration. Yeah. So now we have to start up a Pulsar. But wait a second. But we need to first change the S3 access key and secret key in the ENV. Replace these with what you generated. This is the secret key. This seems to be fine. Right. So we have the environment variables in the file. Let's source the file. So yeah, we copied the files. We changed the access key and secret key. We got the config files in place. Now we have to run Pulsar after sourcing the SH. This standalone mode. You can see that Pulsar uses Zookeeper. There's a lot of configuration. Yeah. So it uses Bookkeeper. Bookkeeper is a persistent data store which Pulsar uses by default as a first class storage. It is actually Bookkeeper's ledgers which get offloaded to Cortex S3 or any storage backend. Okay, so let's see where we are. Okay, the broker service is starting. Things are starting up. Oh, this is a nice log to look at. So the offloader utils is, if you see here, it searched for offloaders in our offloaders folder. It found two offloaders. It found one offloader here. It loaded it. Then it found another offloader. So these two correspond to the two NAR files which we saw earlier. Okay, let it do its job. Meanwhile, yeah, in our Pulsar admin terminal, let's run this. Let's look for stats of a test topic. Oops. Let me rename this as Pulsar. I messed up and used this terminal for the wrong job. But anyways, so I have to go to Apache Pulsar home to be able to run this admin CLI commands. So what I'm doing here is that I'm saying for the Pulsar instance at this URL, for the persistent topic public default test, give me the stats interval. So the name of the topic is test, the namespace is default, and the tenant is public, I guess. I'm not sure what is the reasoning behind the names, but you can understand why this is what most deployments will need. Like they need some tenant, they need namespace for topics, and then the topic. You need to isolate different applications using the same book. That is right. So as you can see here, there is no topic found. It's a 404. Now you can set the offload settings for this namespace public/default using this command. Uh, this is not necessary to be done because we have done this already in the configuration, but this is to show you guys a way to set things if anything goes sideways. I'll add a comment in the doc here explaining that. It is not necessary, but it is good knowledge in case if you want to set any policies. Right? What are we doing with this command? We are saying that for this namespace public/default, the maximum block size Pulsar has to use while offloading data is 8 MB, and the threshold size is 8 MB. So after the topic size crosses 8 MB, Pulsar will opportunistically find some time and offload the data to storage backend. In our case, the storage backend is Cortex S3. That is the endpoint here. So this is the driver which we are using, driver name. This is the this is the bucket where we are going to offload topic data to. Okay, so Pulsar is up now. Now let's try out something. Let's see if we are able to do some sanity check. We should be able to run Pulsar consumer. What does, wait, yeah. Oh, by the way, before doing any of that, let's see whether we have just set the offload policies. Remember, let's see if this stuck. We are going to do a get query on the same and see if the whatever we have set here have taken effect. Okay, it should not take so much time normally. Okay, so we have the offload policies here. You can see all this is stuff which we have set, and some more like how many threads you want to use, you want the offloader to use, and so on. Anyway, so yeah, we are going to do admin actions later on this stuff. Fine. Next, setting a Pulsar subscriber, reader, producer for test topic. Okay, so that's why I have 3 terminals here. So we are first going to do some sanity test on Pulsar, whether it is working fine or not. So we are going to publish messages on a topic and then subscribe to the topic and print them. Hit install Pulsar client. I already have the package, so it was faster for me. Yeah. Okay. I have to first cd into the repos folder. So you go to Cortex, set up for docs, integration, Pulsar, ls. Yeah, this is where my Pulsar subscriber is. I'm going to run Pulsar subscriber. What this does is it subscribes to the topic text test, and I have to go Pulsar. I cd into the integration folder. Now I will publish. Let's say let's publish 10 messages onto the top. Producer 10. See, we have received 10 messages. the message starts here and ends here. So you can see each message has an ID. It starts from 0 to 9. So if you run the publisher again, it again starts this number from 0 because it is stateless. This second part is the message ID. And it has two parts. This is the first number. There are 4 numbers here. The first number is the ledger ID, where this message is stored in Bookkeeper, and the second is the ID of the message within that ledger. Let's continue. We got the subscriber running. We published some few messages and we checked that it works. Pulsar does its job. Now let's do some heavy stuff. Let's publish 100,000 messages quickly. Okay. So as you can see, this is the number index of the message sent by publisher, but within Pulsar, this is the ledger ID and the ID is 625. That's because we already had sent 10 messages earlier. That makes sense. Now we are seeing all the messages. Actually, it's much faster than this. Probably std out is what is slowing it down. Okay, publish as many as you wish and see that the messages are received. Yes, sir, we have done that. Now, let's take a look at the internal stats. The top. As you can see, the topic is pretty busy now, so it might take some time to get the stats. So we have some time, I guess, so let's speak ahead. You should see stats like this. What do these stats have? It has a bunch of ledgers, a few cursors, and some bookkeeping stuff here, which we need not bother about. But cursor is okay. The cursor, what this says is that we have a subscription from a client, which in this case I think is, for example, the Pulsar subscriber is a subscriber. It subscribes with a subscription ID. So the cursor keeps track of how many messages this subscriber has consumed, what is the read position at the ledger. In this ledger, this consumer has consumed up until this ID, messages until this ID. That is what this says. And it still says that the state is open, so the subscription is alive. Oh, we have the actual message, so this is much better. So this is the cursor. Yeah, this is the subscription from our Pulsar subscriber. It had by then read 22,500 messages, and this is the read position. These are the ledgers which Pulsar maintains so far. This is the ledger ID. As you can see, that is what we see here. Why are the number of entries 0? Because this ledger is not done yet. It is still updating. And moreover, this is a linked list. So the current state, if you want to update the current state here, it's going to be slow. That's why the uh, state is at the top level here. So the number of entries added is 22,513 at that point in time. The ledger size is this many bytes, and the last confirmed entry is this, and the ledger state is open. So this ledger is still open. So as you can see, the offloaded attribute here says false, which means this topic is data is still with Pulsar/bookkeeper. Let's wait for until we have enough messages in the top. How much the total size of topic is 4 MB until 22,000 messages, right? So if you remember, we had set 8 MB as the threshold for offload. It does not guarantee an offload after 8 MB. It just says offload will succeed only after 8. That is the threshold. So we did more than double of 22,000 messages. So that would mean we must have crossed the threshold value, right? So let's try and let's go to the next step. Let's try and offload messages. So here we are saying asking Pulsar to offload messages from this test topic. So this is the fully qualified name of the topic, whether it is persistent or not. Tenant namespace topic name. So we triggered the offload. Let's see if it does something in Pulsar. Meanwhile, we were earlier looking at ledger number 10, right? So the current ledger number is 10. Let's continue. Okay, so Pulsar, this is Pulsar log. So Pulsar received the offload instruction. So it started, it says starting offload operation. The total size is this. It is more than the threshold size, right? Yeah, it is more than 8 MB. It says no ledgers to offload because it decided that I'm not going to offload it yet. As I said, it's not a guaranteed operation for offload to happen. So we are finishing off the messages until 100,000. Oh, have you noticed this? The ledger number has changed. So somewhere along the way, the ledger was closed. One ledger was closed, and the next one was opened by Pulsar. Let's take a look at the internal stats. We will understand what is going on. Okay, the topic is still busy, almost done. Okay, the stats should be available soon. Yeah. Or it is still taking time, or maybe that's because yeah. So as you can see, Pulsar created a new ledger. Now the earlier ledger can be offloaded because it is done. When it is done, offload, it is eligible for offload. Right. Now metadata is prepared for offload. Uh, yeah, the newly created ledger's ID is 38. What's going on with the ledger number 10? Read timed out. Okay, why did this happen? Let's see. Let's take a look at how the S3 server is doing. We will connect to it from AWS ls. So something is down in the S3 server, otherwise this would have succeeded by now. Oh, okay, it did succeed. Okay. We timed out is the issue. Fine, let's trigger the upload again and hope it succeeds this time. So this Pulsar offload code is also pretty nice. If an offload fails, an offload is a set of multi-part uploads, right? So if it fails during that process, it cleans up after itself. It deletes all the whatever parts it has created and then leaves. But it's not 100% guaranteed cleanup, because what if Pulsar process came down while cleaning up? So we might have to write some tasks to clean up partly filled multi-part uploads in S3. Periodically we have to go and check for those and clean them. Okay, so starting offload operation. At message this going to offload ledgers 10. Hopefully this time we will succeed. Metadata prepared. Found previous server attempt. Okay, this time it is not going to succeed. Oh, thank God. So the offload operation completed successfully. So that is the demo. We were able to offload messages to the backend. So how do we prove this? So this is the plan, right? We were able to offload messages to Cortx S3. How do you do this? Two ways. One way is based on the internal stats of the topic. Let's get the internal stats. If you remember earlier, this is the internal stats. there are two ledgers, 10 and 38. Offloaded is false for both of them. You can see that the current ledger is 38. That's why it is here. Current ledger size and entries is here. So after 89,515 entries, ledger 10 was closed and 38 was opened by Pulsar. Now we expect the offloaded to be true. Yay, so offload succeeded for ledger number 10. Ledger number 38 is not yet done. It is still accepting entries, that's why it is not offloaded. And these ledgers are immutable, so that is cool. That allows many things to be done. That offload is possible because of these immutable ledgers. Let me restate it. Offload is possible in such a neat and easy fashion because of immutable ledgers. Anyway, so we just proved that the messages are offloaded based on internal stats. Let's cross check in Cortex S3. How do we do that? We will ls the buckets. Oh, we already had the bucket. We created the bucket earlier, remember? So check the bucket now. See this? This is ledger number 10 and this is the index of ledger number 10. So we proved that the offload succeeded. Now let's replay the data from the earliest message. So now we have moved the data from the topic here, right? How do we know whether this data is usable again? How? We will show that Python reader is able to play back the messages from the earliest message in the topic. Let's go to the folder of integration. Python Pulsar reader. Okay, if you see this is message from ledger number 10, ID 0. We started from 0 to 9. We published 10 messages first, if you remember. These are those first 10 messages. Then it starts from 0 again. These are the next 100,000 messages. That's how this reader is able to read data from the beginning of the topic. But let's wait and see if we are able to read data from the next ledger as well. How many messages did ledger number 10 have again? Oh wait, it moved. So you can see that we're able to receive the messages from ledger number 38 as well. So seamlessly we are able to get data from S3, earlier messages from S3, and then the newer messages from bookkeeper/Pulsar. Okay, and I think that is the end of the demo. Thank you very much.